My name is Mick Slodmel. I'm a student teacher in the Bachelor of Physics Education program at the University of British Columbia. Today, we're going to build upon our knowledge of tension, forces, and free body diagrams to find out what we can discover about pulleys. A pulley is a simple machine. It has a wheel with a grooved rim around which a cord passes. It can be used to change the direction of a force, and it can be used to reduce the force required to raise heavy weights. Let's think about that first part. It can be used to change the direction of a force. Consider a system where we're holding an object with a string, and this would be the free body diagram for that. It has the force of gravity pointing down and the tension pointing up. We're applying this tension upward to oppose the gravity. We can do a mechanical advantage calculation. Let's call the force that the mass experiences the output force, and the mass that we exert the input force. If we divide the output force by the input force, we get 1 because they are equal. Hence, this is a situation with a mechanical advantage of 1 or no mechanical advantage. Obviously, we shouldn't expect a mechanical advantage if we don't even have any mechanics. Using this U of A simulation, let's see how we can redirect the force using a pulley. In this case, the free body diagram for the mass is the same as before, but we can pull down and the object moves up. The pulley, in this case, redirects the force. The mechanical advantage calculation is the same as the previous case. We have added a pulley, but our output force and our input force are both equal. So again, we have a mechanical advantage of 1 or no mechanical advantage. I recreated this situation in the physics lab using some lab software and measuring equipment called Verniers Logger Pro, and I'm using a force sensor. In big letters behind me is the force that little box is measuring. So here we can see that basic setup where I'm holding the mass system with the string and the force sensor. You can see that this applied force is in that range of about 2.4 to 2.7 newtons. And you can see, obviously, as you expect, the mass moves the same amount of distance that my hand moves. I have some red arrows on here. They represent the forces. And the blue arrows show the distance that the object has moved. I have created this single pulley system in the physics lab. You can see that the force applied is in that range of 2.4 to 2.7 newtons. You can also see that the mass moves the same amount of distance that my hand moves. In this case, the distance is in opposite directions. My hand moves down and the mass moves up. You can see red arrows for force and blue for distance. Okay, so we added a pulley and we didn't get a mechanical advantage. Not yet. What about that second part of our definition, though? We said pulleys are a simple machine. It has a wheel with a grooved rim around which a cord passes. It can be used to change the direction of force. Okay, we saw that. And it can be used to reduce the force required to raise heavy weights. So how could that work? Okay, well, one way to do that is to add a pulley at the bottom as well, like in this setup. So let's draw a free body diagram. What I like to do is draw a circle around the part that moves and then do a free body diagram for that. This way we don't have to worry about what goes on inside of the circle, and we can just consider how the whole moving piece works. It has force of gravity pointing down, but it has 2 tensions pointing up, right? Because there's the 2 strings coming out from there. We know that tension is equal all along the same string, and we know that it isn't accelerating. So these forces must be balanced. So we can see that tension equals half of the force of gravity. We know that our tension force is the applied force, so we can call that the input force, and the weight at the bottom is the output force. So if we do a mechanical advantage calculation now, we can see that F output over F input is actually 2. So this system has a mechanical advantage of 2. We only need to pull half as much as we would need to pull to lift this object. We can see in the simulation again that the force that we're applying is half of the force that's applied to the mass. Cool. We're back in the lab, same sensor, new pulley setup. Again, we still have red arrows for force and blue for distance. So now notice when I pull it, the applied force is around half of what we saw before. So again, this isn't ideal conditions, so we're just looking for about like roughly. The other thing to notice is that the distance that my hand moves is a lot more than the distance that the mass moves. It's actually twice as far. So in this case, we're doing half the force, but we're actually moving twice as far. Pulleys are used in many applications, and you can increase the mechanical advantage by adding pulleys. If the pulley reduces the amount of force needed, it will need it to be pulled more by that same factor. Students sometimes believe that the mechanical advantage is just the number of pulleys, but this is not the case. It's easiest to calculate it using a free body diagram. Consider the following situation. Can you calculate the mechanical advantage? After that, try out these simulators linked in the comments.